So we looked at the molecular or atomic description of pressure, which is associated with the left-hand side of pressure times volume proportional to temperature, right? And we found this relation. N is the number of molecules or atoms or little balls, what have you, times the average kinetic energy. This can be written as 2/3 N times the mass of each molecule or atom or little ball times the V squared average over 2, the kinetic energy. And we started with saying that that was some constant times temperature. So P times V is equal to, let's keep this N, the number of molecules, and let's introduce a different constant. It's called Boltzmann's constant. And so we can see that KB times T is, we're just getting rid of the N, so that is 2/3 times this average kinetic energy. Oops. And so we have a notion of temperature, right? This is a macroscopic quantity, and we have a connection between this macroscopic quantity and the average kinetic energy of the system. Each molecule has some average kinetic energy, and that's what temperature is. So it follows from this that this average K is equal to 3/2 KB times T. Let me get this right. Times T. And so the total, we can talk about the total kinetic energy, 3/2 NKB times T. And we can have, if we know the temperature, then we can determine the average speed of the molecules or atoms or balls or what have you. And that average speed would be, right, because here this is the mv squared over 2 term, and so that v there becomes, right, we're going to multiply by 2, divide by the mass, so the 3 will remain. We'll have a 3, we'll get rid of the n, kBt over the mass, and that is the connection with the temperature. We can find the average speed of these molecules or atoms or balls.